Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss a new concept regarding the jet propulsion. So this is also similar concept regarding the impact of jets, because the jet propulsion will be created from the impact of jets only. So up to now we have discussed many conditions regarding the impact of jets. Now we'll see what is jet propulsion. So the jet propulsion, actually it is a method of propelling a body. It is a method of propelling a body forward direction by ejecting a high velocity of jet of fluid in the opposite direction. So this is the definition of a jet propulsion, or we can say that it is a propulsion mechanism in which the fluid is expelled a high velocity from a orifice or nozzle, and which producing a reaction force in the opposite direction. That is as per the Newton's third law of motion. So let's try to understand what this definition explains. So jet propulsion is the method actually to propel a body in a forward direction by ejecting a high velocity of fluid. Okay, that fluid may be a gas or it may be a liquid, you can say any kind of liquid can be considered, or gas may be considered, and the opposite direction. So as per the Newton's third law of motion, it says that every action is an equal and opposite reaction is there. Okay, whenever some action is there, there will be obviously some reaction will be there. So what it means to say, suppose if you are giving some, here I have taken one small example, that jet propulsion for a tank. Suppose this is the tank is there and the water is some liquid is filled in this. So here water is given, that's why I have taken the water here, and which is having a height of from this position, and at this from this the water is coming out from the tank at this point. So this is the outlet of this, you can say. So when the and this tank is situated in a frictionless position, and this is the frictionless wheel. Okay, so now though the fluid is coming out from this here, from this tap, you can say, or from a nozzle, so this is called a jet of water. Okay, this is called a jet of water. Now the jet of water which is coming out from here, this jet of water will be give a opposite reaction force. Okay, a opposite reaction force. So how much velocity of fluid is coming out from here, that defines that how much movement will be there in the opposite direction. That means when the fluid is coming out here, okay, with a velocity, at the opposite side there will be an equal and opposite reaction will be there, and that reaction will be as a force. That reaction is nothing but a force will be there in the opposite direction. Now when the velocity is coming out, suppose this is the jet of water, the velocity jet of water. Similarly, due to this, there will be a opposite reaction will be there, and that is force, as I told you, and this tank is going to move in the opposite direction. So this tank started moving in the opposite direction because of this force which is created here. Okay, that's why it's taken by the Newton's third law of motion. So Newton's third law of motion, what is saying, that every action has an equal and opposite reaction. So if suppose this is the action is there, this is the action, and this is the reaction is there, that's it. So this is called jet propulsion by ejecting a high velocity of jet. Now you can see, suppose this is the velocity of jet which is coming out from the tank. So and the fluid in the opposite direction, so the fluid will be moved, or that body will be moved in the opposite direction. Okay, so this is the definition of a jet propulsion. So this jet propulsion can be used in many areas, many applications are there in this. So some applications I have taken here. So it is this application of jet propulsion used in many engineering fields, like it may be a gas taken or it may be liquid. So here you can say the air, and it can be water as a gas and liquid. So basically in the aeronautical field, we can use this for a jet engines for the airplanes. Okay, that airplanes may be different types are there again. It may be turbojet or turbofans or ramjets. So these are the different kind of engines are there, actually the name of these engines also. And in the aeronautical field also we can use this one in the missile field or in the rocket propulsion system also. Similarly, in the marine engineering also you can use this, like the water jet propulsion system for a boat, for a jet skis and high-speed ferries. Even in the marine engineering also, underwater vehicles and torpedoes also you can use. Okay, And similarly, in the industrial and mechanical system also, it can be used for the reaction-based pumps, or we can use for the hydraulic nozzles and firefighting jet systems. Okay, these hydraulic nozzles will be used for the cleaning and cutting purpose. We know previously also we have studied one topic that with the high velocity of fluid jet, we can cut some kind of materials also. Even for cleaning purpose, we know that it can be used for the cleaning purpose. Even apart from this also, we can use in the automobile conditions. Like if I give an example, like in the automobile conditions, automobile area also, we can use for a high velocity of engines, okay, or high speed vehicles. When we prepare, that impact or this applications will be there in the automobile conditions. So this jet propulsion will actually, it is categorized in different types. One is you can see based on the working fluid. It is actually, we can say based on the working fluid. So this working fluid will be maybe like a gas or maybe a liquid type is there. So in the gas jet propulsion, it may be a rocket engine or jet engine, what we have seen here, jet engine for the airplanes. So in the liquid propulsion, it may be a water jet boats or hydraulic jet ejectors. It can be called as a hydraulic jet ejectors. Even sometimes some books also given it is in different ways, like it may be air breathing jet engines. Sometimes it is called, this is called air breathing jet engines. Okay, so air breathing jet engines means what? That the basic fuel will be here atmospheric air. The air will be the basic fuel on that, and another one will be there, that is non-air breathing engines. Okay, so what are the examples will be there in this? I told you that that's turbojet, turbofan, and gas propulsion, ramjet, scramjet. This all the things like it is coming under the air one, and liquid one we can say non-air conditions. Okay, so these are the types of jet propulsions, and these are the application of jet propulsions. Even the jet propulsions also applications will be in many fields, as I told you. Even some kind of even animals also, it can be used for the animals. Some few animals are identified in the sea that this concept or this jet propulsion are used on them. So some animals are there actually, so that I can say the name here. Okay, so their functionality is like similar kind of jet propulsion. They'll release some kind of high speed of water and they'll move, they'll be swim in the sea water. It's very high speed, we can say. So like you can say one salve one animal is there which is to move with very fastly by reacting, or you can say by spreading some kind of high velocity of fluid, and it will move. Okay, so that will be give a reaction to that animal. Another one is there, that is cephalopods. Okay, this is called cephalopods. So this is also one kind of animals in the seas which is visible there. So similar kind of action is identified like jet propulsion type is there actually. So we'll see some kind of advantages and disadvantages also there. Here I've taken. These are some advantages of jet propulsion. For aircraft and rockets, this provides a high speed. All these things are advantages I'm talking about for aircrafts, for marines, and for general engineering advantages. So for aircrafts, you can say this provides a very high speed and with high thrust to weight ratio also, like high thrust weight ratio in the sense this is called compact design. This is called actually compact design, and it can be operated in the space also, and efficiency at high altitude, and for supersonic speed. The supersonic speed will be calculated from the Mach number. Okay, and for marine jet propulsions also, it is high maneuverability and quick accelerations, and there will be no external propeller, and it will be safe for the swimmers and marine lives, and less vibration and mechanical noise will be there for marine jet propulsions, and can operate in shallow water. Okay, for the general engineering advantages, we can say that fewer movement parts compared to the propeller systems, and capable for producing continuous and smooth thrust. The thrust is important. Okay, reliable at high loads and harsh environment also it can be used. So these are some advantages are there. Similarly, some disadvantages also there in the jet propulsion. Now similarly, if I consider this is a for air breathing jet engines, so it is high fuel consumption. The fuel will be used more here, especially for the low speeds. Okay, and expensive, obviously expensive to design and manufacture and to maintain that also. The maintenance costs also more in that. And obviously slightly noisy will be there. That noisy in the sense more sound will be produced here, causing the noise pollution in near to airports. And for poor performance at the low speed, as you can see that low speed we are having high fuel consumption as well as performance also slightly reduced, and it requires advanced material to withstand at the high temperature, because when it is running with high velocity or high speed, you can say at that time it will produce a high temperature. So we need to identify the advanced material which can sustain at the very high temperature. And for rocket engine, obviously again fuel usage is more that costly. So costly due to the cryogenic fuels and precision components. So cryogenic fuel is very costly and difficult to guidance and for control because of the high speeds, and cannot be throttled easily. So difficult to throttle. And for the high safety risk, you can say it is a explosive fuels, and for marines propulsion, and lower maintenance efficiency at the low speeds, already I told you, and more expensive than the other propeller system, requires high power pumps and impeller, more complex maintenance due to the internal pump system. So overall, if you see the disadvantages of all these systems, will have mostly like cost effective and maintenance, okay, and low speed performance. At the low speed, the performance are very weak, and some noisy is there. These are the general we can write. These are the disadvantages. Advantages, we can write many more advantages are there. We can choose a few of them. So basically, this concept actually, if you tell me to like what are the basic concept in this. So basic concept is nothing but very simple. If you see, this jet propulsion is working based on the Newton's law of motion. This is first point you can see, because there is a reaction from the fluid jet. Every action is having a reaction. So when the jet is moving, a jet is giving an impact on the body, okay, there is a equal and opposite reactions are there. So due to this reaction, it works. So this fundamental concept is Newton's third law of motion, okay, which is saying that equal action is having equal and opposite reaction. This is one point. And if you want to write also, we can write that equation will be like we can say F equal to mass into acceleration, and from that we can find out this mass into the mass flow rate into V2 minus V1. What is the velocity and what is the velocity final one and initial one. So this can be written, or you can say this is exit velocity, this is inlet velocity also you can write. Similarly, types we can see, these are the types are there, like non air breathing jet engines and non air breathing jet engines, or you can say gas jet propulsion, liquid jet propulsion. Okay, these are the types are there. Similarly, advantages and disadvantages I told you. Apart from that, one more thing I'll tell you, this all these high velocity jets what we are talking, so this concept is coming under from the Reynolds number. Reynolds number. So when you're talking about Reynolds number, obviously we need to, as per the Reynolds number equation, we know that rho VD or rho V will be mu. So that means density matters, viscosity matters, and velocity also required. So viscosity and density, if it is fixed, then we need to go for the velocity. But when you're talking about high temperature, there this property will be changed. So these are the concepts of this jet propulsion. In the next topic, we'll discuss some types of jet propulsion application types, and based on that we'll be seen like how these equations are coming out from the jet propulsion for different areas. So I hope you understand this lecture. Still, if you are having doubt on this, you can give a comment on the comment box. Thank you all.